Okay, so let's try to find an equation that'll give us this tangent graph right here, right? And so remember that tangent and cotangent are really just shifts and transformations of each other. All right, so you can think about this as a tangent or a cotangent. And we're going to start off with thinking about this as a tangent graph. Okay, so let's see here. Um, Probably the easiest thing to do still is the vertical shift, which is just wherever your axis of symmetry is. So our vertical shift here is going to be 2. Not too bad. All right. And then now that we have that, right, let's remember that the graph of tangent looks kind of like this. We have a vertical asymptote, we have a vertical asymptote, right? And then tangent kind of snakes its way through just like that. Okay. So our whole tangent graph is right over here, basically. I'll use this one since it's the most visible. All right. There we go. And this is one full period of tangent that I'm drawing here. Okay. And so we're going to save amplitude for last because that's the hardest thing, right? But we can talk about the horizontal shift. So the horizontal shift, we're supposed to have that this middle key point, right, where it touches the axis of symmetry, actually goes through the origin. So then the horizontal shift of this graph will be how far removed this point is, right, where it touches the axis of symmetry, right? And let me try to draw that a little bit better. It's way over here, actually, where it touches the axis of symmetry, right? That is our horizontal shift, that distance right there. Okay. So our horizontal shift in this case will be 3.5, right? Which is 7/2. Okay. 7/2. Okay. And then now, so we've done a vertical shift, we've done a horizontal shift. Let's talk about period. The period for the tangent and cotangent is the easiest thing to do. It's just the distance between your vertical asymptotes. So this distance right here between here and here, right? That distance is your period. Okay, so t will be equal to, well, let's see, you're going from 3/2 up to 11/2, basically, right? Let's just count it this way. It's a half a unit, 1.5 units, 2.5 units, 3.5 units, and then another half unit would be 4 units. Okay, 4 whole units between them. Okay. All right, so now we have that. So the very last thing we want to do is amplitude. And the easiest way to do this is by finding out where your key points are. Okay. So let's start with the x values here. Your first key point is this vertical asymptote right here. Maybe I won't use blue since I'm using blue already. I'll use green. Okay. Your first key point is right here at this vertical asymptote. So that's going to be your x1. Your last key point is at this next vertical asymptote. So that's going to be your x5. Now, halfway in between your two vertical asymptotes is your middle key point right here, x3. And remember that corresponds to where the graph actually crosses the axis of symmetry right there. Okay. And then next, right, halfway in between x3 and x5. So let's be very careful about this and count the number of little squares between them. 1, 2, 3, 4, 5, 6, 7, 8. So then 1, 2, 3, 4 units between them. That would be halfway in between. That's your x4. Okay. Halfway in between x1 and x3. So that's 1, 2, 3, 4 units between them. Right. And this is x2. So now we have our x coordinates, x1, x2, x3, x4, and x5. If we want to find the amplitude, right, which is really just a vertical stretch, like it's incorrect to say amplitude, but we're calling it that anyway. So if you want to find the amplitude for this tangent wave, right, then we got to look at where the y value is at either x4 or x2. Okay, so that's this point right over here, right? And then now the distance between this y value and the axis of symmetry, that is your amplitude, right? So that distance right there, right? So let's see, that's half of a unit though, right? Because this is going from 2 to 2.5, right? So the amplitude would be 1/2 in this case. Okay. All right. So that's the hardest thing to do for tangent and for cotangent, but we got it now. Okay. So now that we have that, okay, now we're ready to try to write the equation of this thing. So our amplitude is still just the absolute value of A. Our tangent graph is supposed to go from negative infinity up to positive infinity as we go from left to right. So this is a right side up tangent graph, which means that our A is positive. So then we're going to have that our A will be equal to 1/2. Done with that. Okay. Our vertical shift still equal to D. And so that's going to be equal to 2. So that's our vertical shift. Now we have our A and we have our D. Okay. Our horizontal shift. Oh, sorry. Our period. So the next thing we want to do before horizontal shift. Our period, for sine and cosine, it was 2 pi over b, right? Because the period of sine of x and the period of cosine of x is 2 pi originally, right? But for tangent of x and cotangent of x, the period is pi originally. So then the period of this transformed tangent wave will be pi divided by b, okay? So pi divided by b is your period, which is equal to 4. And then now we have to solve for b, right? So we'll multiply by b on both sides. We get pi is equal to 4b. Now we'll divide by 4 on both sides, and we get pi over 4 is equal to b. Okay. Now we'll do the horizontal shift here. Now the horizontal shift is this distance right here, 7/2, but it's also just given by c over b, right? So then c over b is equal to 7/2. Okay. And then now we have to solve for c. So we multiply by b on both sides. We get c is equal to 7 times b over 2. We'll plug in that b is pi over 4. So we get c is equal to 7 times pi over 4 times 2 is 8. So 7 pi over 8. Okay, and then now we have our c. So our final equation here that will give us this graph is y is equal to 1/2 times tangent of pi over 4x minus 7 pi over 8 plus d is 2. And there we have it. So that's our tangent, right? But like I said, you can think of it as cotangent as well. So let's do this for cotangent now. And a cotangent wave, right, still has two vertical asymptotes, right? And it's supposed to go like this, starting at positive infinity and going down to negative infinity. So it's an upside down tangent graph, okay? So already I can tell that using this as my cotangent graph, I'm going to get a negative a value because it's upside down, okay, from what we need it to be. Okay, so our a is definitely going to be negative there. Another thing to watch out for is that actually when we start doing our horizontal shift, we should note that, use black here if I can. It'll let me click on it. Give me 1 second. Seems to really want me to use this one. But why? I like all colors. Ah, there we go. Okay. So now, something we should be aware of is that when we're doing cotangent, right? When we're talking about a horizontal shift, well, the original cotangent graph is supposed to have its first point being its first key point actually being that vertical asymptote, right? So that vertical asymptote is supposed to lie on the y-axis. So we'll get there in just a second. Okay. Amplitude is still defined the same way. Vertical shift is still defined the same way. So let's start with that. So our vertical shift is this distance right here. Vertical shift will be equal to 2. Okay. Now let's see. Our period is still defined the same way. Still the distance between the asymptotes here. Okay. Okay. So it's still 4 units. Okay. So now we have that. Now let's talk about amplitude. Okay. So for amplitude, right, we're going to do the same thing we did before. This is our x1. This is our x5. Halfway in between them where it touches the axis of symmetry, that's our x3. Halfway in between x3 and x5, that's our x4. Okay. So then tracing that back up to where it touches the graph, right? We see that the distance between that point and the axis of symmetry, that's going to be our amplitude, which is equal to 1/2. Okay. Now, let's do the horizontal shift. So remember that for tangent, we were looking at the distance between this middle key point and the y-axis. But for cotangent, right, we would be looking at the distance between this vertical asymptote here and the y-axis instead. Okay, that's how far it's been shifted over. So our horizontal shift then will just be equal to 3/2. Okay. So now we're ready to find out what A, B, C, and D are. Our amplitude is always going to be the absolute value of A, right? But remember that we have an upside down cotangent graph here. So this is going to be equal to negative A. Okay. So negative A equals 1/2, which means that A is equal to negative 1/2. Okay. So good. Now vertical shift is always equal to d, which is equal to 2. Good. Okay, so now we have that. Let's go on to period. Period is equal to pi over b still, right? Because it's a cotangent. So tangent and cotangent is just pi over b, right? So pi over b is equal to 4, right? We solve for b, and we still get that this is pi over 4. Okay. Now the horizontal shift still equal to c over b, right? So c over b this time is equal to 3/2. So we solve for c. We get that c is equal to 3b divided by 2. We plug in what our b is right over there. So we're going to get this is 3 pi over 8. So then the equation of our graph is y is equal to negative 1/2 cotangent of pi over 4 times x minus 3 pi over 8 plus 2. All right, and that's it.